Next up, we have Hart Montgomery talking to us about how to properly open source code. Let's welcome Hart.
Awesome. Can everybody hear me? Great. Thanks a lot. Let's get started. I am Hart, and today I'm going to talk about how to properly open source code. This is going to be a little bit different from your typical RWC talk, but I hope it's useful for you on your journey when moving your cryptography into real-world production. So I'm going to start by going over some open source background, and I'm going to talk a little bit about why open source and the Linux Foundation, or really why you should care about my opinion on open source principles. I'm going to go over some basic open source table stakes like software licensing, IP protections, and best security practices. And then I'm going to talk a little bit about open governance and building an open community. I'm going to assume you want people to use your code in the real world. This is RWC after all, and the usual disclaimer, I'm not a lawyer. So let's get started. Why do we open source code? Well, one of the reasons, and one that you all are probably very familiar with, is so that others can examine, verify, and learn from our code. It allows people to trust code, and open sourcing has many benefits for things like software security, which many other speakers have alluded to today. As I say, you wouldn't trust a crypto system without a publicly available paper, so why would you trust cryptographic software without a publicly verifiable implementation? But there are other reasons to open source your code as well, and these typically fall under collaboration. There are many economic efficiencies of open source. I'm not going to go into this today in much detail, but a large ecosystem around a piece of open source ensures that, say, if one organization goes away, development continues. This is very important for things like security. Open source has really won in the modern development ecosystem. So even for closed sourced applications, typically 90% of an application's code base is open source. And this is due to these economic efficiencies. Again, I'm not going to spend much time on this, but I do want you to know that the Linux Foundation has a lot of market research on this topic. If you need to convince your boss or management or whatever that you should be able to open source your code. And the Linux Foundation focuses on this collaboration. When multiple companies, entities, or individuals want to collaborate on open source software, but don't trust one single party to own the code, they turn to the LF. And I don't want this to turn into an infomercial for the LF, but I do want to present some facts and figures that show you that we generally know what we're talking about when it comes to open source best practices. So at the LF, we're behind some of the most critical projects in the world. You probably know the kernel. We also have things like Kubernetes, most of the world's telecom stack software, things like the Academy Software Foundation, which runs the animation software for movies, RISC-V, Finos, many other things. And here are just some numbers. I'm not going to read these all out, but these are pretty big annual numbers for open source contributions. I will also give some folks here shout outs. We have a fair number of advanced cryptography projects at the Linux Foundation, and I see many familiar faces in the room, so thank you for your contributions. Right, so let's talk about some basic table stakes for open source software. Well, let's start by saying what open source software is. Here's a definition of open source software, which I won't read, but I want to point out the critical word here, which is license. And the license is the legal document that enforces the set of legally allowed things you can do with code. There are three main types of open source licenses. There are business licenses, which are typically very restrictive software licenses that require payments potentially to a developing company for use. There are copyleft licenses like GPL, which means that modifying the software requires you to contribute back any derivative works. And there are permissive licenses, which mean that you can essentially use the software however you like. So I'll start by mentioning business source licenses. These are technically not open source licenses. They're what's called source available licenses. The source code is public, but limited to certain users. It's viewed as a compromise between proprietary software and open source. And I encourage you to use a BSL license for your code if you want to be able to control who uses your code, like it were closed source, but you want people to be able to independently verify and study your code. So think of like a crypto paper review. If we move on to copyleft licenses, These require users to make available all derivative works. I'm not going to define what a derivative work here is, but if you modify the code and you use it in something, you typically have to make the source of that, something available for free. I will say these are very hard to use commercially. As this sort of quote from Richard Stallman indicates about the ethos, they're not public domain licenses. We unfortunately see a number of people that use copyleft licenses with the idea that they will increase contributions back to code bases by essentially legally requiring them. The unfortunate reality is people these days are just not likely to use your code if there are any viable alternatives due to the potentially cumbersome legal requirements. And finally, there are permissive licenses, and these are things that let you do whatever you want with the code, basically. Most commercially used open source software and most Linux Foundation projects are licensed with permissive licenses just because it's very easy to use. And we generally recommend you default to permissive licensing unless you have a compelling reason not to do so, because it just maximizes the number of users of your code base. So a couple of common licensing pitfalls that we see, and I don't really have time to go over these, but be careful with code you use. We see a lot of people get, say, an LGPL dependency wrong, so be careful about that. And we also see issues with licenses that don't have IP protections. Be careful around those. Right, so in summary for licenses, pay attention. We generally recommend using Apache 2 because it has explicit patent grants, particularly if you're not trying to directly monetize your code. And if you want to make your proprietary code base visible, you may want to try a BSL license. And that last point sort of leads me to this, which is other legal IP and copyright protections. What happens when contributors to open source software unintentionally or maliciously add code that has some sort of IP protection to your open source project? The effects are usually not pretty good. So when you have a Wikipedia article on a series of lawsuits, that doesn't usually indicate that things went well. This is from the sort of infamous SCO Linux disputes. The DCO policy was created out of this. So we recommend that if you have a project and you allow outside contributors, you use either a developer certificate of origin or a contributor license agreement. A DCO is particularly easy to use. This is the DCO right here. I apologize for the darkness on the screen. It's very easy to set up on GitHub. You can just use commits signed with the -s flag. So yes, we require these kinds of IP protections for all LF projects. You should too if you allow outside contributions. And if you don't, people will be justifiably less likely to use your code. All right, let's move on to security. So I know everyone here is familiar with computer security of many types, and it's important and essential, but I do want to bring up a couple of things that are different for particularly large-scale open source projects. And these are vulnerability disclosures, software bill of materials or SBOMs, and software and artifact authentication. And I will say we have a nice sub-foundation of the Linux Foundation called the OpenSSF, which has answers and guidelines for sort of all of the things you need to be doing for your basic open source software security. I encourage you to check it out for more details. So remember that one advantage of open source software is that community members can find and report bugs, and you want to make this as easy as possible for them. Friction is bad. It doesn't really matter what you do as long as it's easy to find and follow. A lot of our projects have recently adopted the GitHub tooling. And let's talk about the software supply chain. So earlier I mentioned that 90% of code was open source and even closed applications. And it turns out that modern developers typically build in a way that looks like this sort of development hamburger. They typically choose a framework that's open source. They use open source libraries to solve problems, and then they write custom code to kind of connect everything and tie it all together. Of course, this brings to mind the famous XKCD comic that I think several other speakers have already brought up in this conference. Obviously there are a bunch of software supply chain attacks that you all are probably familiar with. And you might think that, hey, this isn't so common. That's not true, actually. So in the latest Black Duck open source security and risk report, which went over something like 1,000 code bases across a bunch of industries, Well, the vast majority of these commercial code bases had vulnerabilities. Many of them were high risk, out-of-date components. So it's pretty much a disaster out there. But hopefully your project can avoid some of this by using SBOMs and keeping dependencies up to date. So we encourage everyone to keep track of all the code you pulled in. If there are bugs, you obviously need to fix them and update quickly. Do some due diligence about the dependencies you do have. And we typically find that well-run open source projects are extremely careful with their dependency choices. There are a lot of good tools to help you with this. The OpenSSF has a tool called Guac, which is simple and nice. And finally, I'll say that if you build a popular open source project, people will attempt to impersonate you. This constantly happens to LF projects. I had to deal with a somewhat clever NPM impersonation this week even, and there are plenty of tools for this too. If you're not familiar with SigStore, this is a great tool for this kind of thing that you can just use out of the box. Right. So finally, I'd like to talk a little bit about building an open community. So recall our definition of open source software. An important term here, sort of at the very end, is this collaborative public manner term. And what does this mean and why is it important? Well, the freedoms provided by the license allow for large and diverse communities to form around popular open source software. You can think of things like the Linux kernel or the Apache web server or Kubernetes. And when we mean open source, well, we do mean open source, which is just a public repository of code, but we also mean open development. And this is when there's a community actively building open source code in the open. And then even better is open governance, which means that procedures and roles for the community, how decisions and priorities are made for the project, things like the roadmap, are all openly defined and managed. And we typically see that the more open governance a project has, the easier it is for that project to attract contributors and users. And just some examples of open source government we see as we move from the continuum from sort of closed to open. We have some projects, well, we don't have these in the LF, but there are some projects called public demonstrations, which is essentially just a code dump. Then we sort of have open source projects called open products, again, not really in the LF, but this is when a company or entity open sources a piece of software that's a product. It doesn't really allow outside contributions, but it keeps a roadmap, has regular releases, follows best practices, and so forth. Then there are benevolent dictator projects, which is when an organization allows outside contributions, but sort of ultimate authority still belongs to this benevolent org. And then finally, we have true open governance, which is when code with, we have code with transparent documentation, decentralized meritocratic governance. It's hosted under a third-party nonprofit entity, and technical participation and leadership is completely open. And I will say, whatever you choose, document your governance, and I encourage you to have as open governance as possible because it will mean you will likely have more contributors and more users of your project. With that, I'll conclude, and thank you for your time, and I'm happy to answer any questions.
Thanks for the very informative talk. I didn't see BSD on your slides. I would put it in the permissive license category. Is that right? What's your take?
Yes. Yeah, I apologize for not listing every license.
Okay, but you're not like, you wouldn't like not recommend it. You like Apache 2 better, but like it's.
Yeah, I mean, most permissive licenses are compatible in the sense that you can relatively easily use code licenses one in another project or relicense or so forth. We have lots of projects that are MIT licensed, for instance. We and I just like Apache 2 the most because of that explicit patent grant. So yeah.
Thanks.
It's not a question, but it's more a remark for the audience. I'm an open source developer, and I strongly encourage anyone who is doing open source to try to use the GitHub Action best practices because it's amazing.
Yeah, definitely.
One more quick question.
Hi, sorry, thank you for the talk. It was very interesting. Maybe that's a dumb question. You mentioned some copyleft license and license that ask you that if you use this piece of software, then you should be open source and stuff like that. How do you make those licenses apply when you're a small developer or like a small organization? Because, I mean, yeah, how do you do that?
So how do you enforce license provisions? You have to use the legal system.
Okay.
Yeah,
But
there's no better answer, unfortunately, but yeah. If someone breaks the law, then you have to use the legal system.
yeah, okay, but we don't all have access to the same amount of money and the same amount of we can't use the legal system. Like Microsoft does not use the legal system in the same with the same powers. And I don't know, you're a random developer in Nebraska, right?
Oh, I totally agree. But this is a much bigger problem than just software licensing.
Okay, thank you very much.